I'm James Geary. I'm a senior consultant at Cass Allen. We are acoustics consultants and we work in the construction industry. Today I'm here at Nine Elms. This is a Midgard project in the centre of London. We are on a 49-storey tower and we're doing some sound insulation testing today. So for acoustics within buildings, we are working to Approved Document E, also known as Building Regulations Part E. Approved Document E includes regulations for sound insulation between adjacent properties like flats and houses, etc. So there are two types of criteria, one for airborne sound insulation, which is airborne noise, such as the noise from speaking or from a television, and then there's impact noise, which is generally affected by things like footsteps, especially if you have a hard floor, someone's walking in hard-soled shoes, or if you move a table or a chair on a hard floor. That's the kind of thing that comes through. So we carry out two kinds of tests to quantify the levels of sound insulation for airborne noise and for impact noise. So the reason that we have these regulations is effectively to allow everyone to have a reasonable level of protection from noise from their neighbours. And the building regulations aren't particularly stringent, so it's not uncommon, like on a site like this, for them to aim for a higher performance. In this case, it's 5 decibels higher than building regulations. So sound insulation testing is effectively creating noise in one room and then measuring the amount of noise that transfers through party walls and party floors into the adjacent room. So the noise is generated with a piece of equipment called a minerator, and in the case of an airborne sound insulation test, we generate pink noise, which is a mathematically generated signal that has equal sound power in different octave bands. It means that when we carry out the test, we're able to measure the sound level difference at all frequencies between 100 Hz and 3150 Hz. That's what we measure within a sound test, although the minerator generates noise all the way down from around 20 Hz to about 20,000. So for an impact sound insulation test, we use a tapping machine. In this case, I have a Norsonic machine. It generates impacts to the floor, and then the test is different from an airborne test because instead of measuring a level difference, we're measuring the physical noise level in the room below. The piece of equipment that I use to take measurements is called a sound level meter, and our one is a B&K 2250. Our 2250 is a calibrated piece of equipment, which means it's a lot more accurate than taking noise measurements on a phone. That's one of the reasons why we have to use such an expensive piece of kit, because it's very high precision. So we measure the reverberation in a room. As you can hear in this room, is fairly what you might call echoey, i.e. the reverberation time is quite long. As you can see, there are no curtains and we're currently in an unfurnished room. So once this place has been fitted out and there are soft furnishings, curtains, carpets and things like that, you'll find the space sounds a lot drier. Now, when we carry out our test, we use a starter pistol and we measure the time it takes for sound to decay, and that is used in our calculations when we carry out the test. A typical problem might be impact noise, so they're hearing a lot of footsteps on the floor above them, and when that happens we can carry out an investigative test where we'll use the impact machine and we'll see if they are complying with the building regulations. And sometimes this could be down to, sometimes a failure might be down to the fact that there's been workmanship issues on site, or maybe a resilient layer has not been fitted to the floor, and there are issues like that. And then when that happens, we can advise on how to improve the impact performance. So I've got a degree in music technology, and they're obviously not very linked, music and acoustics, but they are slightly linked. And that's a fairly common path, and a lot of my colleagues are also musicians. So we have people from different backgrounds like music and physics and maths and acoustics as well. It wasn't until I was at uni that I discovered that this was actually a job and that there weren't any building regulations. And it's not just sound or acoustics in buildings, but there's a whole other array of it, such as monitoring construction noise, environmental noise impacts from new commercial units, or whether someone wants to install some new plant on their side of their building. So there's a very wide range of acoustic problems that we can deal with.